Hi, welcome to my presentation. This presentation is a project for Machine Learning Foundations for Product Managers, offered by Coursera and Duke University. For this project, I am working with the combined cycle power plant dataset. I have AT, ambient temperature, V, exhaust vacuum, AP, ambient pressure, and RH, relative humidity, as independent variables and net hourly electrical energy output, PE, as dependent variable. I'll use Excel to fulfill the compare two models and optimize requirements. I'll compare two models, simple linear regression and multiple linear regression. First is linear regression model. The regression analysis reveals how different environmental variables affect the net hourly electrical energy output, PE. The data set includes four features: ambient temperature, AT, exhaust vacuum, V, ambient pressure, AP, and relative humidity, RH. First, I divided the 9,568 dataset. I use 7,653 dataset to create the model and predict the electrical energy output, PE, and use 20% of the data as testing dataset, which is 1915, to validate the model. I use linear regression as first model, the baseline, to formulate the relationship between AT, V, AP, and RH to PE. My finding shows ambient temperature, AT, is the most significant predictor. And at my next slide, the regression statics will show the confirmation of my findings. There is a strong negative correlation between ambient temperature and energy output. As the ambient temperature rises, the power plant's output decrease. Exhaust vacuum also have statistically significant impacts, but it is secondary to temperature. Relative humidity has the least impact. This slide presents the result of the regression statics from four features: ambient temperature, vacuum, ambient pressure, and relative humidity. It shows the ambient temperature, AT, is the most significant predictor. And vacuum, V, also have statistically significant impacts. Relative humidity, RH, has the least impact. The p-value also confirms such findings. I also draw the scatter chart with equation, R-square, and trend line to better visualize the correlationship between four variable, AT, V, AP, RH and PE. To optimize the model, I choose ambient temperature because it is most significant predictor to PE. The result is with a higher R-square and a reduced residual error, the polynomial model demonstrates improved precision and better captures the underlying data trends. I'm performing multiple linear regression to understand if the electrical power output is simultaneously influenced by several interacting environmental factors. I'm using all four independent variables, AT, V, AP, and RH, to predict one dependent variable, PE. The multiple linear regression is a superior choice for this project. I'll explain the reason when comparing the simple linear regression and multiple linear regression later on. After formulate my equation, I validate it with my testing data. The significance f is close to 0. The coefficient is close to 1. The y is closely straight line related to x. R-square represents 89.5% accuracy. This finding indicate the model is considered a good model. As mentioned earlier, multiple linear regression is used because it provides a mathematical framework to simultaneously account for multiple environmental and operational factors that collectively determine electrical energy output, PE. Relying on a single variable would be insufficient, as power output is a complex thermodynamic result of several interacting inputs. To validate the outcome, I formulate the equation and validate with testing data. According to the findings, coefficient is close to 1. Y is closely straight line related to x. The f is close to 0. R-square represents 92.47% accuracy. The model is considered a good model. My final analysis indicates that multiple linear regression is the superior choice for this project. This determination is based on two primary statistical metrics. First, higher R-square on multiple linear regression. This means multiple linear regression is more effective at explaining the variance in the electrical energy output based on the input variables. Second is lower RMSE, root mean square error, on multiple linear regression. A lower RMSE indicates that, on average, the model's predictions have a smaller margin of error compared to the actual recorded power output. This concludes my project. Thank you for your time and attention.